Okay, now I'm getting to a part that often gives people some trouble. You may need to watch this video a couple of times. So here's the deal on naming ionic compounds. So we are going to use a lot of formulas. We're going to use a lot of compounds in this class. We're going to write formulas. We're going to write things. You need to be able to refer to them by name so that someone else knows what you're talking about. So there's a very ordered naming system with a whole lot of rules that we're going to learn. And it's a different naming system for ionic compounds and covalent compounds, molecular compounds. Ionic compounds we're going to do first. Ionic compounds are much more complicated to name than covalent compounds. So, here we go. All right. When we name ionic compounds, really, before I say anything, I should say naming ionic compounds is actually really, really simple. All ionic compounds are made up, and this rule doesn't change. This is the general rule that's applied to all ionic compounds. Ionic compounds are made up of a cation, always listed first in the formula, and then an anion. And all we do to name an ionic compound is we name the cation and we name the anion. We don't even have to say how many of each are in the formula because that becomes apparent. So I just name the cation, name the anion. So in order to do that properly, we have to talk about how to name cations and anions. So cations are always going to be the metals. The metals break into two categories. Fixed charge metals. Fixed charge metals are the ones we have already talked about. I've actually sort of shielded you from the other type. Fixed charge metals are metals that when they occur in a formula, their charge is always the same. Sodium, always +1. Magnesium, always +2. Aluminum, always +3. There's never a change in what, and I keep writing my pluses almost like they're 4s. Let me write this a little cleaner. 2 plus, 3 plus. So there's no change in what they are. We already know most of these. I'm going to tag on a few extras, and I'll show you a little pattern on the periodic table to help you remember them. The other group are variable charge metals. Variable charge metals are a little wonky. So these are mostly transition metals, like iron. Iron, when it shows up in a compound, could be +2. Or it could be +3. It's hard to know. Cobalt could be +1 or +2. Chromium could be +1, +2, +3, +4, +5, +6, or +7. Any of those. Lead can be +2 or +4. You don't have to memorize all these. There's no reason you need to memorize all these. But my point being, variable charge metals are metals whose charges you can't possibly predict. And I don't expect you to predict them at all because, so these transition metals, we're not going to try to predict their charges. We're just going to classify them as variable charge metals. Now, I think it's easier to describe which are the fixed charge metals. So here's what you need to remember are the fixed charge metals. Metals whose charges never change, that are always going to be the same in every ionic compound ever. Group 1A, right? So group 1A, these are always going to be +1. Group 2A. Group 2A, these are always going to be +2, always and forever. And then there's just a few other weird ones. Aluminum, gallium, indium, which is most of group 3, really. But boron's not a metal, so it's not, I can't just say all of group 3 because boron's not a metal. Aluminum, gallium, indium. These three are +3. Yes, I know that I am actually adding on an extra fixed charge metal beyond what your book says. But I'm doing it because it'll make the pattern easier to see. also zinc and cadmium, which are both +2, and silver, which is +1. So let me show you this nice pattern on the periodic table here. So, oops, not that one. Aluminum, gallium, indium, these 3 are +3. Zinc and cadmium, these 2 are +2, and this 1 is +1. So it goes 3, 2, 1, or 1, 2, 3. It's a nice pyramid, and the charge also tells you how many are in that row. There are 3 + 3s, 2 + 2s, 1 + 1. Okay, so our fixed charge metals are these, which are all +1, these, which are all +2. Now, why am I not messing with these over here? Hopefully because you said these are non-metals. We're talking about metals right now. So these are all the fixed charge metals. Now, all other metals everywhere in the periodic table, all other metals are variable charge. These are the only fixed charge metals. Group 1A, Group 2A, aluminum, gallium, indium, zinc, cadmium, silver. All other metals, mostly transition metals, tin and lead also though, all the other metals are fixed charge. Okay, now that I've hammered that away and said that like 50 times, I can now move on. We name them slightly differently. I'm going to talk about fixed charges. They're the easiest to name. Variable charge are just have an extra little thing. Fixed charge metals have a known charge. It's not necessary to indicate their charge when we name them. So we name them by name of the element plus the word ion. So Na plus is a sodium ion, calcium ion, aluminum ion. By telling you ion, you know their charge, and because they're fixed charge, you know what charge they are. Variable charges are different. Because a variable charge, if I said iron ion, you wouldn't know what I meant, because iron can be +2 or +3. You don't have to memorize that. You don't have to know that. Can be +2 or +3. I need to specify which one I'm talking about. Here's how I do it. Iron 2, iron 3. I say iron ion, but I put in parentheses, in Roman numerals, the charge. So I want you to remember, these parentheses, the reason they show up is because because they follow the name of a variable charge metal, and that Roman numeral is the charge on the ion, nothing more. This may not match any numbers in the formula at the end, but it's just the charge on the metal. Copper 2, right? So this is chromium 4 ion, right? Lead 2 ion, lead 4 ion, and so on. So, for any metal that is a fixed charge, group 1A, group 2A, aluminum, gallium, indium, zinc, cadmium, and silver, you don't need the Roman numerals. All other metals, which are variable charge, you need the Roman numeral. Non-metal ions. So here's how we name the anions. Non-metal ions are all fixed charge, so the charge doesn't need to be specified. However, we do have a little suffix change that we use to indicate that it's an anion, to indicate that it's negative. So we change the ending of the element to "ide." Chloride, sulfide, oxide. I don't need to specify the charge. The charge is apparent from its position on the periodic table. Sulfur is in group 2A, so when I say sulfide ion, you know I mean sulfur 2-. If I said nitride, right, that's N3-. All right? Okay, a few other things. I'll show you the list of all of them, but there's two funny ones. Remember how I said way back, it doesn't happen commonly, but carbon could be +4 or -4, and hydrogen could be +1 or -1. Well, there's name differences. H+ is the hydrogen ion. H- is hydride ion, right? Ide meaning it's going to be negative. Carbon ion, carbide ion, right? So here's the changes. There's a couple that are a little weird. Phosphorus is not phosphoride. We dropped the OR, so it's just phosphide. And sulfide sulfur is just fine. Sulfide. So bromide, chloride, fluoride, hydride, iodide, nitride, oxide, fluoride, phosphide, sulfide, so on and so forth. Okay, hopefully that makes sense. Here's how we actually name the ions. As I said, to name a binary ionic compound, here's how we actually name the ionic compounds. You just name the cation and then you name the anion. We don't need to specify. What the formula is, right? So if you say sodium sulfide, right? This is sodium sulfide. I don't need to indicate this 2 anywhere in the formula, right? Sodium, must be +1. Sulfide must be -2. So this is the only possible configuration, right? So if I said calcium fluoride, right? Calcium is a fixed charge metal that must be +2. Fluoride must be -1. Therefore, the formula must be CaF2. It has to be. There's no other possible combination. Okay. Finishing up here. There we go. All right. So KCl, potassium chloride. This is magnesium fluoride. Sodium oxide, and I haven't done any variable charge ones, so, right? Actually, that's probably harder. Let's do one like this. Okay. Naming things. All right, so this is going to be nickel fluoride. However, when you're naming ionic compounds, you got to stop and think, okay, is this metal fixed charge or variable charge? Nickel is not one of our fixed charge, therefore it must be a variable charge. I now have to put parentheses here. I have to put a Roman numeral that isn't necessarily any number down here, and it's certainly not the number that follows nickel. Remember, it's the charge on nickel. We might have to work backwards to figure that out. In fact, we're going to have to work backwards to figure that out. Now, I'm going to show you a notation that I use. It's not standard or anything. It's just what I use. I put the charge that I know everything is at the bottom. So I know every fluoride ion is -1. There's 2 of them. It must be -2. Nickel must therefore be +2 because it has to neutralize, has to be 0. So this must be +2. What I literally do is I start with the charge of the ion here, multiply it times 2, change the sign, and divide by however many are here. So, to put this into another practice, let's do iron Fe2O3, right? Okay. Well, this is going to be iron something oxide, right? But I got to figure out what that something is. I got to figure out what the charge on iron is. Well, I know oxygen's -2, right? There's 3 of them, so that's a total of -6. So I'm putting my totals up here. This is for one of the ion, and this is for the total. Iron must have a total of +6, otherwise this wouldn't be neutral. Then that must mean, so there are 2 irons, it must mean that each individual iron is +3. Okay, If you don't like this notation, that might be weird for you. You can try this instead. So let me erase what I have. You're looking right here. What you can do, if you like algebra better, you can do an algebra thing. You can say, I've got 2 iron atoms of charge I have no idea, plus 3 oxygen atoms of charge minus 2, and the overall charge has to be 0. So 2x minus 6 equals 0, right? 2x equals 6, x equals 3. Right? You can do it that way. And 3 would be the charge on the iron atom, or the iron ions. Okay. Try naming these. So pause it. Try naming them. Oh, we did iron oxide already. Let me give you something a little tougher. Try that one. And then while you're at it, let me make up one more. There we go. Try all these. Okay. Okay, first one, potassium oxide, right? Potassium is a fixed charge metal. We don't have to put a Roman numeral. We're fine. Down here, strontium, fixed charge or variable charge? Hopefully you said fixed charge. Strontium chloride. Chromium is a variable charge metal. I got to figure out what the charge is on it. Chlorine, each chlorine is minus 1. There's 2 chlorides, so there must be plus 2 on the chromiums, plus 2, chromium 2 chloride. Now, lead, this one's a tricky one I like to throw at people. Each oxygen is minus 2, so there's a minus 4. Plus 4, this is lead 4 oxide. Also, be aware, when you see lead 4 oxide, sometimes people write the formula wrong. They get into this thing where they think they know, oh, this is lead 4 plus, and oxygen is 2 minus, and they think they can do this thing where they swap the charges. If you wrote lead 2O4, or Pb2O4, that is wrong. It's incorrect. You have to reduce it down. The last one, sulfur is minus 2. There's only one of them, so minus 2. This must be plus 2. Each one is 1. This is nickel 1 sulfide. Okay. That is how you name ionic compounds. And I will come back to talk about polyatomic ions next time.